February 23, 2008. A $2 billion American stealth bomber lifted off from a runway in Guam. 17 seconds later, it was a fireball. The two pilots ejected. They lived. The plane, one of only 21 ever built, was destroyed. The cause? 3 sensors got wet. This is the story of why the B-2 Spirit shouldn't actually be able to fly. Why, by the laws of aerodynamics, this aircraft should fall out of the sky the moment it leaves the runway. And the only reason it doesn't is a complex web of algorithms that essentially tricks the laws of physics. The B-2 Spirit cost more than its weight in gold. 21 were ever built. Today, only 19 still fly. It's part of America's nuclear strike force, 6,000 miles of range, 40,000 pounds of bombs. It can slip past radar that would light up any other plane in the U.S. inventory. It's seen combat in 6 countries: Kosovo, Afghanistan, Iraq, Libya, Yemen, Iran. Its most recent mission? Operation Midnight Hammer in June 2025 sent 7 of these bombers 37 hours non-stop from Missouri to drop the heaviest bunker busters in America's arsenal on Iran's underground nuclear sites. The largest B-2 strike ever flown. This plane is the tip of America's spear. But here's what almost nobody tells you about it. The B-2 should not be able to stay in the air. To understand why, you have to understand what they gave up to make it invisible. Look at any aircraft, a fighter jet, a commercial airliner, a bomber. They all have a vertical tail. That tail isn't decoration. It's what keeps a plane pointing forward. When wind hits the side of an aircraft, the tail acts like a weather vane. It pushes the nose back into line. Without it, the plane just spins. Yaws left, yaws right. Eventually, falls. Every aircraft built since the Wright brothers has had a vertical tail, because without one, you don't have a plane, you have a falling object. So why doesn't the B-2 have one? Because a vertical tail is a giant flat surface, and giant flat surfaces light up on radar. In the late 1970s, Northrop Grumman engineers got handed an impossible problem: build a bomber that could fly into Soviet airspace without being seen. The radar signature had to be smaller than a bird. To do that, every reflective surface had to go. The vertical tail, the fuselage, every protrusion. The entire plane had to be flattened into one continuous wing. They made a trade nobody had made before. Remove the tail and hope software could save it. They did it. The B-2 is invisible, and on its own, it cannot fly. A B-2 without computers is $2 billion of unflyable scrap metal. Here's what's actually happening every second the plane is airborne. 24 sensors all over the aircraft are constantly measuring airspeed, altitude, and air pressure. That data feeds into 4 flight control computers. Not 1, but 4. They run identical calculations independently. If any one of them disagrees with the others, it gets voted out. 3 out of 4 computers must agree before any command ever reaches the wings. These computers don't just help the pilot fly the plane, they are the only reason the plane stays in the air. Every fraction of a second, they're calculating where the aircraft is, where it's drifting, and what corrections it needs to not fall. They send those corrections to the wing, to elevons, drag rudders, and a moving piece at the back called the beaver tail, adjusting them faster than human reflexes can process. The pilot doesn't fly the plane. The pilot tells the computer what they want: climb, turn, descend, and the computer figures out how to make the unstable wing actually do it. Every second the B-2 is airborne, those computers are stopping it from tumbling. If they fail, even briefly, the plane falls. So what happens when those computers get bad information? We know what happens. It already happened. February 23, 2008. Andersen Air Force Base, Guam. It had been raining for days. Tropical rain. The kind that doesn't just fall, it gets into things. That morning, the crew of the B-2 named Spirit of Kansas prepared for a routine flight back to Missouri. Major Ryan Link in the left seat, Captain Justin Grieve in the right. During pre-flight calibration, they followed standard procedure, but there was something they didn't know. 3 of the 24 air data sensors on the left side of the aircraft had moisture trapped inside them. 3 out of 24. The flight computers calibrated to those readings as if they were normal. Then, the crew turned on the heating system that warms the sensors. The moisture evaporated. The sensors dried out, but the damage was done. The computers had already locked in the wrong baseline. The plane now believed it was flying 10 knots faster than it actually was. It thought the runway was 136 feet lower than it actually was. At 10:30 a.m., the takeoff roll began. The plane lifted off at the wrong speed. The moment the wheels left the ground, the flight computer switched modes. It checked its sensors. The bad data told it the nose was pointing too far down, so it commanded a violent correction. The nose pitched up 30 degrees at 1.6 times the force of gravity. The wings stalled at 80 feet. The aircraft rolled left. The left wingtip clipped the runway. The plane cartwheeled across the field. The fire burned for 8 hours. Both pilots ejected. Major Link survived with minor injuries. Captain Grieve broke his back in 3 places. The plane was gone. It was the most expensive aviation accident in history. 2 seconds of bad data. 3 wet sensors. A $1.4 billion bomber was destroyed. And just like that, the fleet went from 21 to 20. The factory closed in 2000. There are no more being made. Every B-2 lost is a permanent reduction in American strike capability, and you cannot replace what you can no longer manufacture. Spirit of Kansas wasn't a one-off. The B-2's relationship with the environment is complicated. The stealth coating, the radar-absorbing material that makes the plane invisible, is fragile. Heat degrades it, humidity degrades it, sand erodes it. Every flight slowly eats away at the very thing that makes the B-2 useful. That's why these aircraft live in climate-controlled hangars. Only 2 permanent facilities in the world can house the B-2 long-term: Whiteman Air Force Base in Missouri and RAF Fairford in England. A third location, Diego Garcia in the Indian Ocean, uses specialized transportable shelters that can be set up in about 70 days. The Middle East has none of these, which is why during the 2025 Iran strikes, the B-2s flew 37 hours non-stop from Missouri rather than forward deploy to a Gulf base. The heat, the humidity, the sand, they would have eaten the plane alive. After every mission, the stealth surfaces have to be inspected, retreated, sealed. A B-2 needs about 60 hours of maintenance for every hour it spends in the air. In 2010, a B-2 named Spirit of Washington caught fire on the ground at the same base in Guam where Spirit of Kansas was lost. It took 4 years and over $100 million to repair. In 2022, Spirit of Hawaii suffered a hydraulic failure during landing. The fire that followed destroyed the entire left wing. The Air Force decided not to repair it. The fleet dropped to 19. A bomber that scares every Air Force on Earth, kept indoors like an antique. And all of this, the instability, the maintenance, the fragility, was supposed to be temporary. The B-2 was supposed to be the start of something, not the end. The original plan was to build 132 of these aircraft. The Cold War was at its peak. The Soviet Union was the enemy. America needed a stealth bomber that could break through the most advanced air defenses on the planet. Then, the Soviet Union collapsed. By 1992, the program was capped. 21 bombers ever built, each one costing the equivalent of $2 billion in today's money. The full program ran $44 billion. For 2 decades, no air defense network has stopped the B-2. Iraqi crews, Serbian generals, Libyan commanders, Houthi rebels, none of them saw it coming. They just heard the bombs hit. But the plane is old now. The technology underneath it is from the 1980s. The maintenance burden is brutal. Only 19 are left, and they'll all be retired by the early 2030s. Waiting in the same hangar where the B-2 was built is the replacement, the B-21 Raider. Smaller, cheaper, easier to maintain, designed by engineers who studied every flaw of the original. It first flew in November 2023, and the Air Force plans to build at least 100 of them. Everything the B-21 will be, it will be because the B-2 came first. The B-2 was never perfect. It was just first. In a decade, it'll be gone. But for 40 years, it taught a wing how to fly without a tail. And it taught a computer how to do the rest.